Okay. There we go. Okay. So, number 1 is all of this. The first box on the top left, we have 4, 6, and we have a bubble pointing to the 4 and a bubble pointing to the 6. Zari, what word goes in the bubble pointing to the 4?
Numerator.
Numerator. And what word goes in the bubble pointing to the 6?
Denominator.
Denominator. Good. Because remember, denominator starts with D, so it's the number down below. Okay, then in the box on the top right, we have 1, 6, and we have a bubble pointing to the whole thing. Smith, what word goes in that bubble?
Simplest form.
Simplest form. Now at first you may have been like, I don't know, equivalent, I guess. Well really, there's only one word that could go in there. I forgot. Because there's no word like fraction, but you may also look at that and not immediately say simplest form, but once you look at the words in the word bank, it wouldn't work with composite, or improper fraction, or prime. We've already used denominator. Wouldn't work with mixed number. Could work with simplest form, but let's make sure there's not a better one. Couldn't work with equivalent fractions because we'd have to have more than one. And we've already used numerator, so it has to be simplest form. So sometimes what you do when you're not quite sure is you use process of elimination. If everything else won't work, well then that has to be the right answer. Okay, this box in the middle on the left, we have 2/5 and 4/10. Cullen, what word goes in the bubble below 2/5 and 4/10?
Equivalent fraction.
Equivalent fractions. Equivalent fractions. Now, what would we have to multiply the numerator and the denominator of 2/5 each by to get 4/10?
By 2.
By 2. If we multiplied our numerator by 2 and our denominator by 2, we'd get 4/10. Okay, then the box on the right in the middle, we have 12/4. Michaela, what word goes in that bubble?
Improper fraction.
Improper fraction, because remember, an improper fraction is a fraction where the numerator is greater than the denominator. Our numerator 12 is definitely greater than our denominator 4, so that's an improper fraction. Then in the box on the bottom left, we have 5 and 2/6. Zadie, what word goes in that bubble?
Mixed number.
A mixed number, because remember, a mixed number has a whole number part like 5 and a fraction part like 2/6. So 5 and 2/6 is a mixed number. Okay, last box on the right. We have 4, 8, and 10, 3, 5, and 11, with bubbles pointing to each. 4, 8, and 10. What goes in the bubble pointing to those? Cullen.
Composite.
Composite. Those are all numbers with 3 or more factors. Remember, composite numbers have 3 or more factors. Cullen, what word goes in the bubble pointing to 3, 5, and 11?
Prime.
Prime. 3, 5, and 11 are all numbers with 2 factors. Remember, prime numbers have 2 factors only. Composite numbers have 3 or more. Is 1 prime or composite? Zari.
1 is neither.
1 is neither. Why?
Because it's not odd or neither or
Prime and composite has nothing to do with odd or even. I never said that. I said do not get prime and composite confused with odd or even. Why is 1 neither? And 1 is odd, so that's not an answer either. 1 is an odd number. You can't divide it by 2. That has nothing to do with prime or composite. Why is 1 neither? Aaron?
Because composite is more than 3 and prime is just 1 in itself. But 1 only has itself.
So 1 only has one factor. Prime numbers must have 2. Only 2. Not less, not more, only 2. Composite numbers have to have 3 or more. Not less, definitely more. 1 only has one factor, itself, so it is neither. What about 0? Is 0 prime or composite? Victoria?
Neither.
Neither. Why?
Because
It's not the same reason as Aaron, so you don't have to hear her. Why is 0 neither? Smith?
Because it has all the multiples or all the factors.
It has a never-ending amount of factors, but the even bigger reason is it is not a, Lena?
Number.
Well, not a whole number. It's not a whole number. It doesn't represent anything. Represents nothing. So, 1 is neither because it only has one factor. 0 is neither because it's not a whole number. Prime numbers have 2 factors only, not less, not more. Composite numbers have 3 or more factors, not less. Okay, so now for 2 through 5, you had to write an example of each of the words. Not a definition, an example. So number 2, factor pairs. Who has an example, not a definition? Carla.
An example of a factor pair is when you, it's not a definition, but I wrote down what
Do you have numbers and what they're a factor pair of?
I have numbers of.
Okay, so what are the numbers? What is the factor pair?
The factor pair is 12.
A factor pair has 2. That's why it has the word pair in it. Who has an example of a factor pair? Victoria.
1 and 65.
Well, what are they a factor pair of? So you have to have both of those things. You have to have the factor pair like 1 and 65, but then you have to tell me what they're a factor pair of. Otherwise, I just have 2 numbers. I don't know what they are. 1 and 65 are a factor pair of 65. So your answer should look just like this. You just may have different numbers. If it doesn't, you need to make it look just like this with the numbers that you used. My example that I had on my page was 3 and 5 are a factor pair of 15. So yours should look, you need the factor pair and then of course what they're the factor pair of. Otherwise it's just 2 numbers. I don't know if it's a factor pair or you're just telling me, hey, get 1 birthday hat and 65 candles.
I also have another one.
Well, do you have what they're a factor pair of? Again, even if you have 2 factor pairs, but no, you don't tell me what they're a factor pair of. Those aren't factor pairs, they're just 2 numbers. You have to say blank and blank are a factor pair of blank. Okay? Or you can have like 65 dash 1 and 65, something. But you have to tell me what the numbers are, the factor pairs, and then what they are a pair of. If not, you need to fix that right now. Number 3, greatest common factor. Who has an example, not a definition, of greatest common factor? Zadie.
So I used 2 and 4.
Okay. How did you use them to show greatest common factor? Because if you just wrote 2 and 4, that's just 2 numbers. It's like 1 and 65. It's just 2 numbers. It doesn't show me how they're what greatest common factor means. We don't list the first 4 factors. You're thinking of multiples. Who can help her out? Carla.
Well, mostly you take the numbers that you take 2 and 4,
Mm-hmm.
write down 4 of the 4 common.
Nope, you guys are thinking of multiples. Factors, we don't write 4 factors. We write all of the factors. Maybe it has 4, maybe it has more, maybe it has less. I'll give you my example. I put 3, and then I listed the factors 1 and 3. Then I put 6, and I listed the factors 1, 2, 3, and 6. And then I circled 3 to show that 3 is the greatest common factor of 3 and 6. So if you have something like this, or if you said something like 3 is the greatest common factor of 3 and 6, then it is correct. But you had to do one of those things. Remember, factors and multiples are different. So you can't list the first 4 factors of 3 because does 3 even have 4 factors? No, it only has 2. 6 has 4 factors, but that's just a coincidence. All you had to do was go to the lesson where we learned, find the word greatest common factor in a lesson and see what it did in the examples. And then you could have just copied that, where it found the greatest common factor. Okay, number 4, least common multiple. Who has an example of least common multiple? Smith.
I used 12 and 8.
Okay, and how did you use 12 and 8 to show least common multiple?
I listed their first 4 multiples.
Okay, so for 12, what are the first 4 multiples?
12, 24, 36, and 48.
Okay, and what are the first 4 multiples of 8?
8, 16, 24, and 32.
Okay, so now we have lists of multiples, but how did you show least common multiple?
I found the least common multiples that they both have in common.
Okay, so how did you indicate that?
I circled them.
What did you circle?
24.
24. So similar to that, just like number 3. Or you could have said something like 24 is the least common multiple of 12 and 8. One of those ways. You either could have done it in numbers, like up here, or you could have done it in words, kind of like number 2. Okay, number 5, benchmark fractions. Who has an example of benchmark fractions? Not a definition. Zari.
1/2, 2/4, 3/6, 4/8, 5/10, and 6/12 are examples of benchmark fractions.
Good. Say that again, Zari, so I can copy it.
1/2, 2/4, 3/6, 4/8, 5/10.
Those are good. But all of those fractions are equivalent to what? Which is why they're such good benchmark fractions. They are all equivalent to what fraction? Zari?
1/2.
1/2. That is why those are good benchmark fractions, because they are all equivalent to 1/2. Remember, if you can divide the denominator by the numerator and get 2, that fraction is equivalent to what? Carla?
1/2.
1/2. Okay, so make sure you have good answers. If you already had good answers, don't worry. Just make sure that you have correct answers. Okay, let's go ahead and move on to the next page. Okay, so we are finding the factor pairs, and number 6 is 52. Carla, you're going to help me out. Now, we can't just go through and guess the most obvious. We have to actually test things and try things. But at least we automatically know what is the very first factor pair of 52.
1 is 52.
1 and 52. Because we always know the very first factor of a number is 1. The very last factor of a number is that number. Always. Now, let's look at the number to figure out, is 2 going to be a factor of 52, Carla?
It is because there's a 2 behind
So this 52 is what type of number?
an even number.
An even number. If the digit in the ones place is even, the number is even. 2 is even because we can divide it by 2. So we know 2 has to be the next factor. Do we know it goes with 2, Carla?
Not yet until we divide.
Good, not until we divide. So this is where we move to our separate sheet of paper and we divide it. So if you did not divide, guess what you need to do on your separate sheet of paper with your red pen? You need to go to your separate sheet of paper, you need to find number 6, and you need to test. Carla, 2 goes into 5 how many times?
2 times.
If you did not do this, you need to do this. 2 times 2 is?
4,
5 minus 4 is?
1.
2 goes into 12.
2 go into 12 6 times.
Now I'm going to give you a little tip. We already know 6 times 2 is 12, and 12 minus 12 is 0, right? So do we have to keep going, or did we already find the other part of the factor pair?
You already found it.
We already found it. We know at this point 6 times 2 is 12, and we're going to end up with no remainder. So what's the next factor pair of 52, Carla?
2 and 26.
2 and 26. Now, do we know if 3 is a factor of 52?
We don't know until
We don't know. And is there a basic fact with 3 that equals 52?
No.
No, there's not. So what do we need to do to figure out if 3 is a factor?
Divide.
Divide. So if you did not divide, you need to go to your separate sheet of paper, and with your red pen, you need to show that division. Carla, 3 goes into 5.
3 go into 5 1 time.
3 times 1,
3 times 1 equals 3.
5 minus 3.
2.
Bring down our 2, and now we have what?
22.
Is 3 going to go into 22 evenly?
No.
So at this point we know, is 3 going to be a factor, or are we going to end up with a remainder?
It's gonna have a remainder.
It's going to have a remainder because we know that 3 goes into 22 7 times. 7 times 3 is 21. 22 minus 21 is 1. So we know it's not, is 3 a factor?
We know that.
We know right here that 3 is not going to be a factor because can 3 go evenly into 22 like 2 went into 12 evenly?
No.
No. So we can go ahead and move on. Let's think of 4. Do we know if 4 is a factor of 52?
Not until we test.
Is there a basic fact with 4 that equals 52?
No.
No. So we need to
Test.
test. So go to your separate sheet of paper. If you did not test already, you need to do it with your red pen right now. 4 goes into 5.
4 go into 5 1 time.
1 times 4.
4.
5 minus 4.
1.
Bring down the 2. Ooh, what do we have now?
12. So
12. Does 4 go into 12 evenly?
Yes.
Yes. How many times?
3 times.
3 times. Do we have to multiply 3 times 4 to get 12 and then 12? No, we know we've got it, right?
Yes.
So what's our last factor pair of 52?
3 and 30. 13.
3 and 13?
4 and 13.
4 and 13. Now, lucky us, we know we don't have to keep going, right? Because we don't have any more lines. But what if we didn't? Let's keep going just to see, okay? So that you can see what happens if you don't have lines, okay? Carla, we can look at this number and say if 5 is a factor or not, right? Is 5 a factor of 52?
No.
No. How do we know, without even doing division, that 5 is not a factor of 52?
The way that we know is because 5.
Multiples of 5.
The multiples of 5 have 0 or 5.
Where?
In the one place.
In the ones place. And this has a 2. So is 5 a factor?
No.
No. Now we need to test 6. But wait, let's think. What's 6 times 12? If you know it, call it out.
72.
72. 52 is smaller than 72, right?
Yes.
So that means if 52 is a multiple of 6, there has to be a basic fact. Is there a basic fact with 6 that equals 52?
No.
No. When you're finding factors, think, okay, my next number is 6. 6 times 12 is 72. That's bigger. Think of what the last answer to the basic fact is. If it is bigger than the number you're finding factors for, that means there's either a basic fact with that answer or it's not a factor. 6 times 12 is bigger than 52. There is no basic fact with 6 that equals 52. That means we're done with 6. That means any number greater than 6, there's going to be a basic fact, or it's not a factor. So Carla, is there a basic fact with 7 that equals 52?
No.
No. What about 8?
No.
Nope. 9,
Nope.
10,
Nope.
11,
Nope.
12.
Nope.
We're done with the basic facts. And when you have a 2-digit number you're finding factor pairs for, it's not going to go bigger than a basic fact. So that means 1 and 52, 2 and 26, and 4 and 13 are the factor pairs. Now remember, when we do factor pairs, we do least to greatest in a U shape. So least to greatest. Make sure you have them listed, least to greatest in a U shape. Okay, let's do the same thing with number 7. So find your work for number 7. And Smith, you're going to help me. We have 36. We know what is the first what is the first factor pair?
1 and 36.
1 and 36. Now let's try 2. Is 2 going to be a factor of 36?
Yes.
Yes. How do we know?
Because 36 is even.
Because 36 is even. But is there a basic fact with 2 that equals 36?
No.
So how do we find the other factor pair?
By dividing.
Or the other half of the factor pair? By dividing. So on your separate sheet of paper, you should have 36 divided by 2. 2 goes into 3.
1 time.
1 times 2.
2.
3 minus 2.
1.
Bring down the 6. 2 goes into 16.
8 times.
Do we have to keep going to figure out what the other part of the factor pair is?
No.
No, because we know 8 times 2 is going to be 16. We know 16 minus 16 is 0. So, what's the factor pair? What's the next factor pair for 36?
2 and 18.
2 and 18. Now let's think of 3. Do we have to do division to test? Or do we have a basic fact with 3 that equals 36?
We have a basic fact.
We have a basic fact. 3 and
12.
12 are a factor pair. That means everything else is either going to not be a factor or there's going to be a basic fact. Is there a basic fact with 4 that equals 36, or is 4 not a factor?
There is a basic fact.
There is. What is the next factor pair?
4 and 9.
4 and 9. Now we can look at 36. Well, first of all, is there a basic fact with 5 that equals 36, or is it not a factor?
It's not a factor.
It's not a factor. Even if we didn't have a basic fact, we could look at it. What does it have in the ones place?
A 6.
Multiples of 5 have to have
0 or a 5.
0 or a 5. Let's think of 6. It's either at this point going to have a basic fact with 6, or it's not going to be a factor.
There is a basic fact.
There is a basic fact. What's the last factor pair for 36?
6 and 6.
6 and 6. Now, if we didn't have lines and we just had to list them all, we would think, is there a basic fact with 7,
No.
8,
No.
9, 10, 11, and 12? We've already met in the middle. Oh, whoops, sorry. We could have stopped at 6 because we met in the middle. So we didn't even have to keep going. Sorry. Once you meet here, either you say this number or they're the same number, you can stop. You don't have to guess any other numbers. Because there's definitely not going to be anything between 6 and 9 that's going to be a factor of 36. Okay, 8. We have 23. Mason, what's the first factor pair of 23?
1 and 23.
1 and 23. Now, because there's only 2 blanks, we know we're done. But let's pretend we didn't have these blanks. Would 2 be a factor of 23?
No.
No. How do you know?
Because 23 is not even.
What is it? It's not even because it's odd. So we know 2 can't be a factor. Now let's think of 3. What's 3 times 12?
36.
36. That's bigger than 23, right? So that means we can think, is there a basic fact with 3 that equals 23, or is it not a factor? It's not a factor. Same with 4. Is there a basic fact with 4 that equals 23, or is it not a factor?
It's not a factor.
What about 5?
No.
6,
No.
7, 8, 9, 10, 11, 12, and now we're done with basic facts. We don't have to keep going. Because if there's a factor greater than 12, we're going to find it when we look at the smaller number, when we test the smaller number. Okay, that's what I'm expecting on your test. I'm expecting trying things and knowing basic facts. Okay? I can't remember if on the test there's lines like this or if it just says list the factor pairs. I can't remember. So be prepared for either. Okay, now, oh wait, I don't need to erase. Numbers 9 through 11 say tell whether each number is prime, composite, or neither. Zari, number 9, 0. Is it prime, composite, or neither?
Neither.
Neither. What is the main reason that 0 is neither prime nor composite?
Because anything times 0 would equal 0.
So, but that's not the main reason. What's the main reason? Zadie.
It's not a whole number.
It's not a whole number. Because if I have 0 of something, do I have any of it? If I have 0 pies, do I have any pieces of pie at all? No, I have no pie. So 0 is neither, mostly because it's not a whole number. Okay? Now, number 10, we have 31. Lena, we have to test, right? Because it is odd. Are all odd numbers prime or composite? No. So we have to test. So to do that, we factor rainbow. So go to your separate sheet of paper. And if you did not factor rainbow, which also includes some testing sometimes, you need to do that now. What is the first factor, not factor pair, what is the first factor of 31?
1.
1. What is the last factor of 31?
31.
Is 2 going to be a factor of 31? Why?
Because it's odd.
No, because it's odd. Sorry. Correct. No is the answer because it's odd. Sorry, I didn't mean, yeah. What about 3? Do we have to test or can we use our basic facts to figure out if 3 is a factor?
Test.
Are you sure? What's 3 times 12?
36.
36. 36 is bigger than 31, right? So do we have to test or can we think, is there a basic fact with 3 that equals 31?
There's a basic factor.
So think, is there a basic fact with 3 or is 3 not a factor? 3 is not a factor because what's 3 times 10?
30.
And what's 3 times 11?
33.
31 is between 30 and 33. So can 3 be a factor of 31? We know if 3 times 12 is bigger, then any other basic fact number times 12 is going to be bigger. So now we're just thinking, is there a basic fact with 4 that equals 31? What about 5? What about 6? What about 7? What about 8? What about 9? What about 10? What about 11? What about 12? And we don't have to keep going. So what does that mean about 31?
31 only has 1 factor.
It only has 1 factor?
No.
What does that mean about 31? We found the factors. What does that mean about 31? Why is it prime?
Because it only has one factor.
It only has one factor?
2.
1, 2. It has one factor pair. Guys, factor pairs and factors are different. This is a factor pair. This is a factor. So there is one factor pair, but prime and composite don't have anything to do with factor pairs. They have to do with factors. Prime numbers have how many factors, Lena?
2.
2. How many factors does 31 have?
2.
2. 1, 2. So 31 is
A prime number.
prime number. Number 11, 62. Michaela, we're trying to figure out if it's prime or composite. Do we have to factor rainbow, or can we look at it right away and say whether it's prime or composite?
We can look at it right away.
We can look at it right away. 62 is
Composite.
composite. How do we know that without factor rainbowing?
Because it has 3 or more.
Well, how do we know that it's going to have 3 or more factors just by looking at the numbers?
Because it's even.
Because it's even. That means it automatically has what as a factor?
2.
2. So that means it at least, at the very least, if the number is even, has 1, 2, and itself. There's 3 factors. Composite is 3 or more. Except what number? What is the only even number that is prime? Mason? 2. Because even though 2 is even, what are the only 2 factors of 2?
1 and 2.
1 and 2. So even though 2 is even, it is prime because there's only 2 factors. Every single other even number on the planet is composite. Doesn't matter what it is. Okay, number 12. The directions for this part say, circle the 2 fractions that are equivalent for each set of fractions. Erin, you're going to help me out. So what we need to do, a good strategy is start with the fraction with the smallest numerator. Which fraction has the smallest numerator, Erin?
3/4.
Which fraction has the smallest numerator?
2/6.
2/6. Slow down and look. Now, we want to see, is it equal to 3/4? Can we multiply 2 times anything to get 3?
No.
No. Can we multiply 6 by anything to get 4? No. Can we go backwards and multiply 4 by anything to get 6? Or 3 by anything to get 2? So is our 2/6 and 3/4 equivalent? No. Now let's test 2/6 and 9/12. Is 2 times anything 9? No. Is 6 times anything 12? 6 times 2 is 12, but can we do the same thing to the numerator and get 9? So is 2/6 equivalent to either of these? No. So now let's try 3/4. We already know it's not equivalent to 2/6, but let's test it with 9/12. Can we multiply 3 by anything to get 9?
Yes.
What can we multiply 3 by?
3.
Can we multiply 4 times 3 to get 12? So, what 2 fractions are equivalent?
3/4
3/4 and
and 9/12.
9/12. Do you see how I had to test to make sure? That's what you should be doing. Let's look at number 13. Zadie, we're going to start with that same strategy. Which fraction has the smallest numerator? There's 2, right? So now let's also see, okay, which one has the smallest numerator and denominator?
4/10.
4/10. Let's test it with our next fraction, 4/100. Can we multiply 4 by anything to get 4?
Yes.
Yes. What can we multiply 4 by?
1.
1. Does that work if we multiply the denominator times 1?
No.
No. So that means 4/100 is not equivalent to 4/10. Let's try the next one. 40/100. Can we multiply 4 by anything to get 40?
Yes.
What can we multiply 4 by to get 40?
10.
Can we do the same thing to the denominator?
Yes.
Yes. So we already found it. We don't have to keep testing. What are the two equivalent fractions?
4 tenths and 40 100ths.
4 tenths and 40 hundredths. Let me just tell you, when you do say fractions, make sure not to, and if the denominator is 100, make sure not to say 100 because then it might sound like you're saying 41 hundredths. Do you see how 41 hundredths sounds really similar to 41 hundredths? So try not to say the 1 in front of 100 when you're doing fractions, okay? Number 14. We have 3/5, 1/4, and 6/10. Victoria, let's start with the fraction with the smallest numerator. 1/4. Let's test it with 3/5. Can we multiply 1 by anything to get 3? There's nothing. Yes, I can multiply 3. If I multiply 4 times 3, do I get the same denominator? No. So are 1/4 and 3/5 equivalent? Nope. So now let's try 6/10. Can I multiply 1 by anything to get 6?
Yes.
What can I multiply?
6.
Can I multiply 4 times 6 to get 10?
No.
So are 1/4 and 6/10 equivalent? No. So is 1/4 equivalent to anything?
No.
What's the next smallest numerator? 3/5. We already know it's not going to work with 1/4. Do we have to test it again? No. So let's try 6/10. Oh, whoops. 3/5. Can we multiply 3 by anything to get 6?
Yes.
What can we multiply?
2.
If we multiply 5 times 2, do we get 10?
Yes.
So which fractions are equivalent?
3/5 and 6/10.
3/5 and 6/10. So see how this was all basic facts? It was just a matter of writing it and testing it. And when you're doing it on your own, it goes much faster because you're not waiting for me to be ready, right? Okay, now let's look at the next part. Numbers 15 through 17, we have to write each fraction in simplest form. If it is in simplest form, we write simplest form. Michaela, when we are finding simplest form, do we use greatest common factor or least common multiple?
Least common multiple. Oh, no,
Greatest common factor. So number 15, we have 4/10. What are we finding the greatest common factor for? What numbers are we listing factors for?
4 and 10.
4 and 10. What are the factors of 4?
1, 2, 4.
And the factors of 10?
1, 2, 5, and 10.
The more you factor, the more you're like, oh, I know those factors. I've memorized those factors. Michaela, did you find that you had memorized these factors already by the time you got to this problem? Probably. What are the common factors?
1 and 2.
What's the greatest common factor?
2.
What do we do with that greatest common factor?
We divide it.
Divide what?
We divide 2 by our fraction.
We divide, not the fraction, we don't do this. That would mean we take 4/10 and we break it into 2 groups. Like it would look different. Remember, we divide the numerator and the denominator each by the greatest common factor. 4 divided by 2 is?
2.
So there's our new numerator. 10 divided by 2 is?
1. 100. 20.
10 divided by 2 is 10 times 2 is 20, but 10 divided by 2 is, remember it, think of, if you need help, think of it backwards. Blank times 2 equals 10.
Oh,
5. So 4/10 in simplest form is 2/5. If you do not have all of this for number 15, you need to do it right now with your red pen. Because remember, in order to find greatest common factor, what do you have to list? Class, the factors. If you don't list all the factors, what might happen? Carla,
Something might.
what specifically might happen? Something might go wrong, but specifically what might go wrong? Cullen,
You'll get the wrong answer.
why? If you don't list all the factors, why might you get the wrong answer? Specific.
Because you didn't write all the factors.
Why would that lead you to the wrong answer? Smith,
Because you might have picked the wrong factor.
you might have picked the wrong factor. You might not have listed the greatest common factor. That's why you have to list all the factors. But I'm telling you right now, most of these numbers are going to be numbers like this, where you can think really quickly. What are the factors? Oh, well, 4, 1, 2, and 4. 10, 1, 2, 5, and 10. Most of these fractions are just going to be ones where they have like 3 or 4, maybe 5 factors. Okay, so if you did not put this for number 15 on your separate sheet of paper, you need to do it right now. And if you did not put it for number 15, you probably didn't do it for number 16. So you need to be ready to do it for number 16. Number 16, we have 3/9. Aaron, you're going to help me out. What do we use? Greatest common factor or least common multiple?
Can you say that again?
Number 16, what do we use to simplify? Greatest common factor or least common multiple? Follow the patterns, please. Cullen? Greatest common factor. Aaron? Who was it? Michaela told us we use least, well, first she said least common multiple, and I said nope, and then she said, oh, whoops, greatest common factor. We wouldn't all of a sudden use a different strategy for this one. Follow the patterns. Listen to the person before you. Just because it's not your turn doesn't mean you zone out or start drawing with your red pen. You listen and you follow because you're going to say the same exact thing, just with different numbers. I need every one of you to realize that. Math is doing the same exact thing over and over again, just changing the numbers. So that means if it's your turn to answer a question, say the same exact thing the person before you said, just use different numbers. So if Michaela told us to use greatest common factor to simplify on number 15, what do we use on number 16? Greatest common factor. What numbers are we finding the greatest common factor for? Michaela said 4 and 10. Aaron, what numbers are you finding the greatest common factor for? 3 and 9. Now this is where we have to change a little bit because we can't use the same factors, but we're still following the same steps. Next we list the factors. Factors of 3. 1 and 3. Factors of 9. Is that it? Think in your head. Is 2 a factor? Is 3 a factor? Is 4 a factor? Is 5 a factor? 6, 7, 8, 9. Don't just pick the most obvious ones. Think it through. Go from 1 to the number you're finding the factor for and think, is this a factor? Is this a factor? Don't just pick the most obvious ones because then you're going to end up with 1 and 9. And what's the greatest common factor of here, listed right here? 1, which means this would be in simplest form. But is that true? No, because what is the greatest common factor? 3. That's why it's so important to list all factors. Because then you might miss one, and then you end up with the wrong answer. So, now we found the greatest common factor. Michaela said that we divide the numerator and the denominator each by the greatest common factor. Do we do the same thing here? Yes. 3 divided by 3 is 1. 9 divided by 3 is, so 3/9 in simplest form is 1/3. Make sure that you're not just picking the most obvious factors. Make sure you're thinking through. What are all the factors? Because if you miss one, you might miss the greatest common factor, and then you end up with the wrong answer. You've got to go slow, take the time, and put the effort in to make sure that you have the right answers. Okay, number 17. We have 3/10. Mason, to simplify, do we use greatest common factor or least common multiple? Greatest common factor. We have 3/10. What are we finding the factors for? 3 and 10. What are the factors of 3? Hey, I'm going to give you a hint. Where else did we list the factors of 3? Number 16. Are the factors of 3 going to change all of a sudden?
No.
So let's just copy the factors from number 16. 1 and 3. Now we have to list the factors of 10. But wait a second, didn't we just list factors of 10?
Yes.
Where? Number 15. So let's copy those factors.
1 and 10.
Oh, tell me in order, not factor pairs. Factors.
1, 2.
1 and 2 are the only factors of 10. Copy from number 14. You were either supposed to copy it from up here or already have had it. Mason, let's think. We know 2 is a factor. Is 3 a factor of 10? 4? Think of your basic facts. Is 4 times something 10? 5? Confidence, please. 6? Is 6 times something 10? 7? 8? 9? 10? And we're at the numbers, so we don't have to go higher. But in number 14, we had already listed the factors of 10, so I shouldn't have had to even think about that again because I could have just copied it from number 15. But remember, Mason, we can't just stop at 2 because are those all the factors of 10? No, because what does 2 go with? 5. And what does 1 go with? 10. So now, Mason, what are the common factors?
1.
What's the greatest common factor? 1. Who remembers the definition of simplest form? Victoria.
It's when your fraction, the greatest common factor is 1.
When the greatest common factor of the numerator and the denominator are 1, it's in simplest form. So, do we have to do this, Mason? No, because we already know if 1 is the greatest common factor, then that fraction is already in simplest form. I just want to tell you guys, when you're not showing all the work, then you're missing out, because if you show all the work on number 14 and 16, that means you don't have to find the factors of 3 again. You can just copy the factors from number 16. And you don't have to find the factors for number 10 again. You can copy the factors from 15 because you already have them. So make sure you're showing all the work. Don't just stop on number 15 because you found, 1 and 2. Oh, look, that's it. And then you stop. Because then you're potentially messing yourself up later. And also, what if we had different numbers and 2 was not the greatest common factor? 2 is not always the greatest common factor. Sometimes it is, a lot of times it isn't. So don't just stop because you're like, oh, that's it. Check, test. Put the time and the effort to make sure you have it correct, not just finished. Okay, Mason, make sure that you copy those if you don't have all of these factors for number 14 or 17, or 15 or 17. Okay. Now we're moving on to numbers 18 through 20, where we have to compare. Use greater than, less than, or equal to. It says check your answer with using fraction tiles or number lines, but we're not doing that. Victoria is in an emergency. Okay, we'll talk about it later then. Carla, you're going to help me with number 18. When we compare and order fractions, do we use greatest common factor or least common multiple?
When we compare,
Least common multiple. Remember, I wrote it on the board yesterday morning. I said, when comparing, use LCM. Or I think I might have said use LCM when comparing. But either way, I wrote on the board exactly when to use it. I said, when you simplify, use GCF, greatest common factor. When you compare or order, use LCM, or least common multiple. I wrote it on the board. But if you don't pay attention and you just go really fast to get finished, then you don't have that practice. You didn't look at that hint, which would have told you, go to the lesson that has the vocab word, least common multiple, and it'll tell you how to compare. So, Carla, number 18, if you don't have this work shown, everybody, make sure you're showing it with your red pen. We have 5/8 and 1/3. Step 1, find LCM. What are we finding the LCM for? Numerators, denominators, or all four?
we have to look for the multiples of 8 and 3.
So the denominators. Let's list the first four multiples of 8.
8, 16, 24,
'Guys, you've got to know your basic facts. Call it out if you know it.
32,
Okay, what are the first four multiples of 3? Carla?
3, 6, 9, and 13.
Call it out if you know it.
12.
12.
You've got to know your basic facts. Next year is going to be really, really hard if you don't know your basic facts, because we're already past where you learn them. At this point, you have to know them in order to move on. Okay, do we have a least common multiple yet?
Not yet.
Not yet. So we need to list 4 more, but I'm going to give you a hint. Start with a smaller number. Which one's smaller, 8 or 3?
3,
So let's list the next 4 multiples of 3.
15, 18, 21, 24,
Have we found, so we just listed the next 4 of 3. Have we found a least common multiple yet?
yes.
Yes. Now, the reason I told you to go with the smaller number is because then we found it, so we can stop. What is the least common multiple?
The least common multiple is 24.
So we don't have to list 4 more of 8 because we already found it. Okay, what was the point of that? What do we have to do with these fractions that we started with now that we found this least common multiple, this LCM?
Now that we found the LCM, we see what we multiply to get the
Why? What is 24 going to be now? Who can help her out? 24, oh, Carla?
24 is going to be the denominator.
The new denominator. So we have to take each of these fractions and turn them into an equivalent fraction with our least common multiple as the denominator, which means we just have to find the numerator. To find that, what did we do to 8 to get 24, Carla?
We multiply 3 to 8.
So that means if we do it to the denominator, do we do something different to the numerator?
We don't do anything different.
No, we do the same thing. Whatever we do to the denominator, we also do to the numerator. So 5 times 3 is?
15.
Which means 5/8 is equivalent to?
15/24.
So I'm going to come over here, and I'm going to write real small, 15/24 underneath 5/8. Because that tells me 15/24 is equivalent to 5/8. Now I do the same thing with my other fraction. I start with 1/3, and I know it needs to equal a fraction with a denominator of 24. Well, what did I do to 3 to get 24?
You multiply by 8.
I multiplied by 8. Do I do something different to the numerator?
Never.
Never. 1 times 8 is?
1 times 8 equals 8.
So that means 1/3 is equivalent to?
1/3 is equivalent to 8/24.
So underneath 1/3, I'm going to write the equivalent fraction, 8/24. Now I have the same denominator. That was the whole point. Now I can just compare the numerators. I have 15 and 8. Remember, the larger numerator is the larger fraction when the denominators are the same. One more time. The larger numerator is the larger fraction when the denominators are the same. So, which one is 15/24 greater than, less than, or equal to 8/24?
It is less than.
Is 15/24 greater than, less than, or equal to 8/24?
It's greater than.
Which means 5/8 is greater than, less than, or equal to 1/3.
It's greater than.
It's greater than. Remember, I'm going to say it again. The larger numerator is the larger fraction when the denominators are the same. 15 is larger than 8. So that means 15/24 is larger than 8/24. Imagine if we had fraction tiles that were broken into 24ths. If I had 15 of them, it would be a lot bigger than if I just had 8. Okay, number 19, we have to do the same thing. Are we changing our process at all? No. We are still going to find the least common multiple, change to equivalent fractions, and then compare the numerators. So, we're just going to go through reading because we need to get this done so we can have our test tomorrow. Smith, you're going to help me with number 19. Our steps, are they going to change orders? No. The only thing that's going to change is what? The numbers. The process, the steps, the operations stay exactly the same. The numbers are the only thing that changes. So, number 19, we have 1/5 and 4/6. The first step when comparing, no matter what, is to
Find the least common multiples for the denominator.
find the least common multiple for the denominator. Not the numerator, not all four, just the denominators. So we have 5 and 6. Let's list the first, just catch up with us, okay? You can unpack later, okay? Well, you can get it later, okay? Okay, first 4 multiples of 5.
5, 10, 15.
Go slow. 5,
10, 15, and 20.
now first 4 multiples of 6.
6, 12, 18,
Oops.
and 24.
Have we found one yet?
No.
No. Let's list 4 more of the smaller number first. Which one's smaller, 5 or 6?
5. 25, 30, 35, and 40.
Have we found a least common multiple yet?
No.
So let's go ahead and list more of 6. But if I get to 1 before I list 4, let's just stop there, okay? So what are the next 4 multiples of 6?
30.
Do I have to keep going?
No.
What did I just do?
You found the least.
I found the least common multiple, which is
30.
30. What am I doing with that least common multiple?
They're going to become the new denominator.
They're going to become the new denominator. So let's start with 1/5. And it needs to be an equivalent fraction with 30 as a denominator. Well, what did we do to 5 to get 30?
Multiplied it by 6.
Which means, what do we do to the numerator?
Multiply it by 6.
1 times 6 is?
6.
So 1/5 is equivalent to
6/30.
6/30. So I'm going to write it small underneath my original one so that when I'm comparing, I know which one is which. So boys, if you don't have this written, you need to write it with your red pen, okay? If you already have it, well then borrow one out of the cup on my desk. Make sure it's not a liquid ink one. Mason, can you help him really quick? Not like one of the liquidy ink ones. Yeah, that's fine. Okay, now we need to change 4/6. What did we do to 6 to get 30?
Multiply it by 5.
So what do we do to 4?
Multiply it by 5.
4 times 5 is?
20.
So 4/6 is equivalent to
20/30.
20/30. What's the next step?
To figure out which one
So we compare the,
fractions.
but which part of the fraction? Do we have to compare the denominators anymore?
No.
No, so we compare the
Numerators.
numerators. The larger numerator is the larger fraction when the denominator is the same. So, is 6 greater than, less than, or equal to 20?
Less than.
So that means 1/5 is greater than, less than, or equal to 4/6.
Less than.
Less than. Make sure you have this for number 19. Because Zari, are we going to change anything at all other than the numbers when we do number 20 together?
No.
No, we're going to do the exact same steps. Find LCM, convert fractions, compare numerators with number 20. So, make sure that you are writing this. Thank you, Ms. Douglas. Make sure that you are using your red pen to write this, unless you already did, in which case, if you already did, you probably have like lots of right answers. If not all right answers. Okay, number 20. We have 2/3. Oops. Sadie, can you close the door all the way? We have 2/3 and 8/12. Zari, what do we need to do first?
Find multiples
Of the
denominators.
Of the denominator. So we're going to list 3 and we're going to list 12. What are the first 4 multiples of 3?
3, 6, 9, and 12.
What are the first 4 multiples of 12?
12, 24, 36, and 48.
Did we find a least common multiple?
Yes.
Yes. What is it?
12.
12. So now we need to do what? What do we do with that least common multiple?
We multiply it to our regular,
Who can help her out? What do we do with our least common multiple? Michaela?
It's going to be our denominator.
It needs to be our new denominator. So we convert fractions so that we have a denominator of 12. Bless you. So we need to change 2/3, bless you again, so that it has 12 as the denominator. Zari, what did we do to 3 to get 12?
We multiplied it by 4.
What do we do to 2?
We multiply it by 4.
Make sure you're writing this if you don't have it already. Zari, 2 times 4 is?
8.
So that means 2/3 is equivalent to
8/12.
8/12. Do we have to change 8/12 so that it has a denominator of 12? No. Why, Zari?
Because it already has 12 at the end.
Because it already has 12 as the denominator. So, now we just need to compare our new fraction, 8/12 to 8/12. Is 8/12 greater than, less than, or equal to 8/12?
8/12 is equal to 8/12.
8/12 is equal to 8/12. So that means is 2/3 greater than, less than, or equal to 8/12?
Equal to.
It's equal. Okay, make sure you have all of that written with either your pencil or your red pen. See lots of red pen writing, even though I told you you had to do this. I wrote it on the board. Thank you to those of you that did. Good job. Are you finding that you got a lot of right answers and you're not having to correct or write much? Probably. Okay. Make sure that you know how to do this because on your test I will be looking for it. I will be looking for this. I will be looking for what we did for numbers 15 through 17. I will be looking for what we did for numbers 6 through 8. So if you have those written with either pencil or red pen correctly, guess what you should study to figure out so that you remember the steps? What do you think you should study so you remember the steps? Carla?
Study what we have on the sheet of paper.
Study what you have on your piece of paper. Your tests look very similar to the reviews. So are you going to do different things on the test? What's the only thing that's going to change on the test? Lena?
The numbers.
The numbers. Until we get to word problems. And then the words also change, but do the processes change? Just instead of apples, you may be working with bananas on your test. Okay? Okay, let's look at the page 3. Number 21. Mrs. Evans has 13 pictures to hang on a wall. Is there any way she can arrange the pictures in rows other than 1 by 13 or 13 by 1 so that the same number of pictures is in each row? Tell whether 13 is a composite or prime number. Explain. Ethan, is it? Oh, you want to answer it? Okay, go ahead, because I was going to take volunteers for the word problems. So, is there another way to arrange the pictures so that there's equal numbers in each row? No. Why? 13 is prime. What are the only factors of 13? 1 and 13. 13 is prime because the only factors are 1 and 13. That's it. We can't make it in any other even rows. Otherwise, we'd have extras. Because what if I try to make, okay, I want to make 6 rows. I want to make 2 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Do I have an even number of pictures in each row? An equal number of pictures in each row? No, this one has 7, this one has 6. Okay, well, I'm going to try 3 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Do I have an equal number in each row? No, these two have 4, this one has 5. Now I don't have to do all that because now I know prime and composite. If I know a number is prime, do I have to do all this modeling and stuff? No, I know there is only one way to arrange them, with 13 and 1. Yes?
If we have something close to that,
If it's close, yes. If you have all of this information written in a different way, you are right. You just need all of this information. No, the answer is no, because the first question says, is there any way she can arrange the pictures in rows other than 1 by 13 or 13 by 1 so that the same number of pictures is on each row? No, she can't. Tell whether 13 is a composite or prime number. 13 is prime. Explain. The only factors are 1 and 13. So we answered all 3 of those parts. If you have these 3 parts, no, 13 is prime, factors are 1 and 13, you're fine. Doesn't matter if you use different words, as long as you have those 3 things. Number 22. There are 2/8 of a cup of peanuts and 1/4 of a cup of walnuts. Is there a greater amount of peanuts or walnuts? Explain. Who would like to answer this question? Zari, what lesson are we going to use? Factoring, simplifying, equivalent fractions, ordering, or mixed numbers?
Equivalent fractions.
Are we going to use equivalent? Are we just trying to figure out if these are equivalent? Does it say, is the amount of peanuts and walnuts equivalent?
No.
No. So are we using equivalent fractions lesson?
No.
No. So that leaves factoring, prime and composite, simplifying, ordering, and comparing mixed numbers.
Comparing.
Comparing. Remember, key words for comparing are greater than, less than, equal to, bigger than, smaller than, longer than, shorter than, whatever. That means you're comparing or ordering numbers. So, that means we are comparing 2/8 and 1/4. Zari, when we compare, do we use GCF, greatest common factor, or LCM, least common multiple?
LCM.
LCM, great. Of what? Numerators, denominators, or both?
Denominators.
Denominators. Okay, first 4 multiples of 8.
8, 16, 24, and 32.
Good, first 4 multiples of 4.
4, 8, 12, and 16.
Did we find the least common multiple?
Yes.
Yes, what is it?
8.
8. So now we have to change the fractions so that what is the denominator?
So that 8 is the denominator.
So that 8 is the denominator. Do we have to change 2/8 to get a denominator of 8?
No, because it already has an 8 as the denominator.
It already has an 8 as the denominator. What about 1/4?
Yes, we do
Yes.
need to change 1/4.
So 1/4 needs to become something 8ths. 4 times what equals 8?
4 times 2.
So that means we need to multiply the numerator. 1 times 2 is,
2.
so 1/4 is equivalent to
2/8.
2/8. Now we compare. Is 2/8 greater than, less than, or equal to 2/8?
It is equal to
It is
2/8.
equal. So that means 2/8 is greater than, less than, or equal to 1/4.
Equal to.
Equal to. So now we need to figure out, is there a greater amount of peanuts or walnuts?
Neither are. There's not an equal. There's not an There's not more than one.
Pause. How can we put that in a sentence? You are right. But how can we put that in a sentence that would make sense to everyone?
There's not more peanuts than walnuts.
Okay? Or we could say there is the same amount. Or there is an equal amount. There we go. So, oops. There is an equal amount. How do we know? Because 2/8 is equal to 1/4. So there's the explain. There's the answer. Is there a greater amount of peanuts or walnuts? Well, the answer is there's an equal amount. Explain. 2/8 is equivalent to 1/4. So as long as you have both of these pieces of information, even if they are worded differently, you are correct. Yes, Victoria.
Is it okay if we
Do you have the same information? Doesn't matter if it's written differently, then you're fine. If you have the same information, you have it in words, in some way, saying that there's the same amount of peanuts and walnuts, in some form of words, and you have the answer in numbers for the explain, then you are correct. If you only have one, you need to add the other. Because the question, is there a greater amount of peanuts or walnuts, asks for the words. The best way to explain is to show the numbers that you figured out on your separate sheet of paper. Okay? Number 23. Who would like to help me with number 23? I'll pick a stick because I have lots of hands. Lena. Mia has 2 whole bananas and 1/5 of another banana. Write a mixed number that represents the amount of banana she has. What is the mixed number?
2 1/5.
Do we say it like that though? How do we say it?
2 and 1/5.
2 and 1/5. 2 whole bananas, 1/5 of a third banana. 1/5 of, so see, 2 bananas, 1/5 of the third banana. So don't let, she has, if it were to say something like she has 1/5 of a third banana, don't let that word third confuse you. It's just saying she has 2 whole bananas. That's terrible. And the third banana, she only has like 1/5 of it. Okay? That's all that means when it says something like she has 1/5 of a third banana. It's not saying 1/3. It's saying the third. Okay, number 24. Who would like to share their real world problem that compares fractions? Keep your hand up if you want to do it. Zadie. I just picked a stick out of the people who had their hand raised.
There are 5/8 cups of syrup and 1/6 cups of pancake.
Here, slow down so I can write it. Even though you don't have to write this, as long as just I'm going to write on the board. So there are 5/8 of a cup of syrup. Is that what you said? There are 5/8 cups of syrup. What was the rest?
And 1/6 cups of pancake batter.
And 1/6 cups of pancake batter.
Is there more syrup or batter?
Is there more syrup or batter? Very good. So you should have something like, there is blank of blank, and there is blank of blank. Is there more of blank than blank? Something like that. If you have something like that, you are correct. So guess what word problems on your test are probably going to look like? Carla.
They are gonna have.
Oh, it's going to look like what? Tell me the words that you're probably going to see.
You're gonna probably see the question.
Well, you're probably going to see there is blank of blank and blank of blank. Is there more or less of blank than blank? You're probably going to see something very similar. Now, Zadie, are we done?
No.
Because what do we have to do next?
You have to figure out is there more.
We have to solve. So, we're comparing, are we using GCF or LCM? If I say GCF and LCM, is everybody going to forget what GCF and LCM stands for? I'll use both. So, GCM, greatest common factor, or LCM, least common multiple? Please said it correctly. I'm glad you're feeling confident today, but you still have to be respectful of the people who are answering, okay? When we're comparing, do we use greatest common factor or least common multiple? Where can you look? Zadie, where can you look? Did we do those on our work before on our other parts of our review? Who can help her out? Would you like to help her out? Do we use GCF, greatest common factor, or LCM, least common multiple, to compare? LCM, least common multiple. Remember, Zadie, GCF for simplifying, LCM for comparing or ordering. So, Zadie, we have 5/8 and 1/6. We know we need LCM of what numbers? Numerators, denominators, or all of them? It's the same thing we did before. Denominators. First four multiples of 8.
8, 16, 24, 32,
First four multiples of 6.
6, 12, 18, 24.
Did we find a least common multiple?
Yes,
What is it?
24.
So what do we do with that least common multiple?
It needs to become our denominator.
It needs to become our denominator. So let's start with 5/8. What do we do to 8?
We multiply it by 3.
Which means what do we do to our numerator?
We multiply it by
5 times 3 is,
15.
so 5/8 is equivalent to
15 24.
15 24ths. Now we need to change 1/6. What do we do to 6?
We multiply it by 4.
So what do we do to our numerator?
Multiply it by
1 times 4 is,
4.
so 1/6 is equivalent to
4 24.
4 24ths. So now we can compare our numerators. Is 15 24ths greater than, less than, or equal to 4 24ths?
Greater than.
Greater than, which means 5/8 is greater than, less than, or equal to 1/6.
Greater than.
Greater than, which means, is there more syrup or batter?
There's more syrup.
There is more syrup because,
5/8 is bigger than 1/6.
ooh, but let's use the math word. Because 5/8 is
Greater than.
greater than 1/6. Okay, last one, number 25. I'm going to pick a stick because everybody should be able to answer that. Which equation is true? Well, I picked Zadie, but since you just picked, I'll pick something else. Victoria, which equation is true? Is it A, 2 2/3 equals 2 plus 2 plus 3. B, 2 2/3 equals 1 plus 1 plus 2 plus 3. Is it C, 1 plus 1 plus 1/3 plus 1/3? Or is it D, 2 2/3 equals 1 plus 1 plus 1/3? Let's, just for fun and for practice, let's figure out what these do equal. Victoria, 2 plus 2 plus 3 is? 7. Definitely not 2 2/3. 1 plus 1 plus 2 plus 3 is? Also 7. Definitely not 2 2/3. 1 plus 1 plus 1/3 plus 1/3 equals? 2 2/3. 1 plus 1 plus 1/3 equals?
2 and 1.
So the answer is definitely C. Okay. Make sure you know how to do everything on this test. This review. One more thing, though, that will be on your test that is not on here. Ordering. Ordering is exactly like comparing, except that you have what? Ordering is exactly like comparing, except that you have 3 fractions. But you do the exact same thing. You just may or may not have to add a 3rd number to find multiples of. One last thing. What are the factors of 100? Who can tell me the factors of 100? Raise your hand if you can tell me the factors of 100. Everybody might want to write these. What do you think that means? Michaela, can you tell me the facts of 100?
Oh, I was going to say, can we write it on the back?
Make sure that the back is done, but yeah. Victoria, what are the factors of 100? 1 and 100.
2 and 50.
2 and 50. Is 3 a factor?
No.
Let's test. Can 3 go into 1?
No.
3 goes into 10?
I know this. 3 times.
3 times 3?
9.
10 minus 9?
1.
Is 3 going to go into 10 evenly? Is 4 a factor?
Yeah.
Do we know? What can you use to remember the factors of 100?
It's 25 because you take 4 quarters.
Money. How many pennies are in $1?
100.
100. How many 50-cent pieces are in $1? 2. How many quarters are in $1? 4. How many nickels, yes. How many nickels are in $1? How many dimes are in $1? 10. Money is an easy way to remember the factors of 100. There is 100 pennies in $1. There are 2 50-cent pieces in $1. There are 4 quarters in $1. There are 20 nickels in $1, and there are 10 dimes in $1. Yes, Carla.
So we know which one which cents is which. Can we write down the names on top of the numbers so we know?
Yeah, because that'll be then you'll get really confused because there will be a lot of writing in one place. So just remember, that means you're probably going to see this on your test. You're probably going to see a number like this. I don't know if it's this exact number. I'm not saying it's this exact number. But you might see one like this, which means you'll have to use that factor rainbows to figure out the other factors. The rest of them are going to be basic facts. Okay, any questions about your test tomorrow? You may not use fraction tiles. You may not use your number lines on the test. may not use your math book. You may not use your anchor charts. Make sure to bring your anchor charts home, your math folder, so that you can use them, especially for converting mixed numbers. Oh, I'm sorry. One last thing you'll need is converting mixed numbers and improper fractions. That's that last lesson we did. So that's not in your book the way that we learned it, and you can use the way that we learned it. So make sure you bring your math folder home so that you have that anchor chart that tells you how to convert mixed numbers and improper fractions. Okay? So everything that's on here, plus ordering, plus converting mixed numbers, improper fractions, and improper fractions. Any questions about the math test? Okay, go ahead and put your review in return to school. It needs to be turned in first thing tomorrow morning. Yes, Zadie.
Along, if the people got into